Hello everyone. I hope all of you are doing great in this pandemic. Today's topic is Introduction to Verilog. And if you have not subscribed this channel, then please do subscribe so that you will get the notification of the videos that I will be uploading in this channel. In this lecture, I'm not going to tell you the definition of Verilog language or who developed this language or what is the use of this language. Rather, I will be discussing what are the topics that I'm going to cover along with all the concepts of Verilog language. Okay. So what you all are going to learn in this Verilog tutorial is the practical aspects of Verilog language, like how Verilog language can be used to design a logic. In this tutorial, not only you will learn Verilog, but also system Verilog and Perl scripting. Okay. So these are the topics that I'll be covering in this Verilog tutorial. The first one is what I'm going to cover is the Verilog language concepts. Okay. So here I will cover all the syntax of Verilog language, then the semantics. Then there are three types of modeling, right? If I want to design, then three different ways I can design a logic. One is gate level, one is structural, and one is behavioral modeling. So this is all about Verilog language. This is what I will be covering. Then the second one is the logic design concepts. And in this logic design, you will be learning the gate level basic gates like AND gate or gate or XOR, MUX, only gate. Then in combinational logic you will learn like MUX, DEMUX, encoder, decoder. Okay. Then in sequential logic you will be learning counter, different type of counter. Then you can say FSM based design, some FSM based design. Okay. So I will cover all these things: sequential logic design, combinational logic design, and gate level logic design. And I will provide all the codes for this one. Okay. So the next one is the memory design. What I will cover in this Verilog tutorial is designing of RAM, then designing of ROM, means writing codes for RAM, then for ROM, and then FIFO based design. Okay. And I will provide all the codes for this one, and I will tell you how to write all these things and what are the concepts. Then the fourth one is FPGA design. Okay. Here you will learn how it functions, means how it works, how we dump the code, Verilog code, and what are the features that a FPGA provides, and different type of processors. Like you must be knowing that FPGA, inside FPGA there is a processor called microblaze. Okay. There is a processor called microblaze processor. Okay. So I will explain about how microblaze processor works and what is the function of this one, and how we can utilize this processor for a particular application. Okay. Then I will be discussing ChipScope Pro, that is Xilinx FPGA. You will get ChipScope Pro, then XPS, then EDK tool, embedded development kit. So these are the things that I will be covering in FPGA part. The function of FPGA, then what are the processors inside the FPGA and how it works, then how ChipScope Pro you can utilize for your design and why ChipScope Pro is used, then what is the use of XPS tools, then what is the use of EDK tools, embedded development kit. Okay. The fifth part that I will be covering is DSP design, means digital signal processing design, and here you will learn multiplier design. See, for any kind of DSP design, the most important part is the multiplier design. Without multiplier there is no DSP design, there is no DSP circuit, there is no signal processing circuit. So I will tell you how to implement, how to write Verilog code for multiplier, different type of multiplier, and different methods to implement multiplier. And in this DSP design, signal processing design, again you will learn this fixed point design. This is very important topic this is, and that definitely I will cover fixed point design. Okay, then you will learn here filter. The different type of filters are there, right? FIR filter, then IIR filter. All these filters I will cover in this DSP design topic, and I will provide you the whole code, means the Verilog code or RTL code for this one, FIR, then IIR, then how to implement this fixed point. Okay, then protocols I will cover, low end protocols I will cover here, and one is the I2C integrated IC, and another is SPI, serial peripheral interface. Here I will explain how it works, how this protocol works, and how the things are interfaced using these protocols, means I2C and SPI. So here I will give complete code, complete RTL codes for this one, this I2C and SPI protocols, and how it works, the functionality of these protocols. Okay, the seventh part I will cover writing test benches, means how to write the test benches, how effectively you can write the test bench using Verilog language to check the functionality of your design. Normally test benches are written to check the functionality of your design. So I will be discussing how to write test benches for your design. Okay, the eighth part that I will cover here is interfacing, then different type of interfacing that you can do with your FPGA. Okay, like for embedded system, like with Arduino, lot of interfaces we can do, right? So like that with FPGA also you can do lot of interfaces, and for that you need Verilog language for that one. So I will cover here this ADC part, analog to digital converter, then digital to analog converter interfacing, then LCD interfacing, then EEPROM interfacing, then RF module interfacing. These are the hardware, these are the real hardware, means I will give you the code, the complete details, how it works, how these real hardwares are interfaced with FPGA. Okay, then I will also explain this predefined IP, how to import predefined IP and to use the predefined IP for your own design, because so many IPs are there. If suppose if you are using Xilinx tools, for writing code, then inside Xilinx software there are predefined IP. Those IP you can use for your design to reduce your time. Okay, normally we use predefined IP to reduce our time, our design cycle, so that the time required for design cycle will be reduced. Okay, so I will explain how to export, how to use those predefined IP. Okay, then the ninth part I will cover is system Verilog. Here you will learn the concepts of system Verilog in details, but I will not cover that methodology part like OVM or UVM. This part I am not going to cover, but this basic part definitely I am going to cover, and you will learn. Okay, the 10th part that I am going to cover is Perl scripting. This is scripting language actually, Perl scripting. It is very famous scripting language, and why it is used normally to run test cases. Okay, normally to run test cases, like writing test bench. You are writing test cases, means you are writing test benches for your design to check the functionality of your design. So it is not like one or two test cases are there. There are thousands of test cases that you have to check. There are hundreds, thousands of test bench that you have to write, that you cannot run that one manually. What you have to do, you have to write a script for that one, so automatically all your test benches or test cases will be run simultaneously one by one. So for that we need Perl scripting. So I will cover here Perl scripting, but you can also use Unix based scripting. Okay, for that this one but mostly I will cover here Perl scripting. Okay, then the last part is interview questions. It is very important topic where I will discuss the industry standard questions and what type of questions they ask to a freshers guy. Okay, so here I will cover digital part, mostly digital part, and industry standard, not what is written in the book. Okay, and some logic design here, mostly logic design FSM based question. Normally they ask FSM based question. Okay, during the interview, and like CDC part, they also cover sometime, they also ask sometime clock domain crossing. What is clock domain crossing, they ask. So I will cover CDC part here, then all those sequential design concept, then combinational design concept, then timing concepts, all the timing questions, timing related questions, then some Verilog related important questions. Okay, like you can say synchronous design, then asynchronous design. This part I will cover. Okay, so these are the things that I will cover in this Verilog tutorial. Okay, so and at the end of this video, only one thing I would like to say, that it is beyond any VLSI training center to teach all these things, to cover all these things. Okay, but if you want to learn all these things, if you want to gain the knowledge, the real knowledge, the practical knowledge, then you have to subscribe this channel and please stay connected, so that you can learn all the digital concept here, and whatever I have written, definitely I am going to cover all these things one by one, but it will take some time. Okay friends, then thank you so much for watching.